Hello and welcome to the fifth video of what you say Dart and Flutter programming. In this chapter we started discussing flow control mechanisms in order to control the flow of your program. There are multiple categories of flow control statements. We have the selection, the iteration, and the jump statement. Actually, mostly the jump statements are used with the switch cases, and we discussed that. And so far, what we were doing is we were talking about checking condition just for a single time or just one time. So the next flow control statement is checking condition multiple times, because some of the statements have to be done repeatedly or multiple times. So when we talk about flow controls or controls with repetitions, we have to first discuss about increment and decrement operators. We've already covered increment and decrement operators when we studied Dart operators, but let's just give a brief overview. So what is the purpose of increment and decrement operators? The purpose is to increase or decrease a value by a given constant or by some constant. By doing this, we can control how many times a statement is done, or to find out the maximum time. So they're helpful in together with repetition flow controls. So they are just a simple arithmetic. For instance, this plus sign adds variable or adds 1 to the variable, and this minus operator subtracts 1 from the variable. So what does val plus plus means? Val plus plus means val equals to val plus 1, and val minus minus means val minus 1. So we've already discussed this kind of assignments in the previous chapter, and we've already tried to show how this works, how a val plus 1 is assigned to val. So to understand that more clearly, let's go back to this picture. So suppose you have a statement which says width equals to width plus 10. So in this case, let's first assume width is equals to 30. So what we are actually trying to do is, we're not going to assign the value of the width plus 10 right away. What we do is, we first compute the value on the right hand side. That means we first compute val plus 1. So in this case, width was 30. So we bring 30 here, and we calculate this value in some other memory location, and then put the value or store the value into the variable. So we store the value into the the width variable. So the same thing, before we increment, when we say val plus plus, what we are saying is val equals to val plus 1. So what we did is, we first compute the value of this, and then assign to the variable location of the right hand side, to the left hand side. So the assignment operator assigns the right hand side to the left hand side. We've said that. So this calculation or computation is held in some other memory location. It's not handled in the same memory location. It's handled in some other memory location, and you should be familiar with such thing. The increment and decrement operators can come before the variable or after the variable. That means they can appear before this val or after this val. And when they appear before, we call them prefix. When they appear after, we call them postfix. And in this case, what happens is, like, we first do the computation and then return the new value of the variable. That means first val plus 1 or val minus 1 will be computed, and then it will be assigned, and then it will be returned. However, in postfix, first we assign the old, we return the old value before we make this kind of calculation. We return, or we give the value that is already existing, and then we increment or decrement the variable. So it is just when the computation will occur, or when this computation will occur. If we want to return the the new value, we put it in front of the variable. If we want the old value and then increment it, we put it behind the value. So this is the use of increment and decrement operators. Once we started discussing repetitions, flow control, or looping, we'll see the use of this increment operator. The most or the first loop control that comes to mind when we talk about flow control of repetition is the while loop. So the while loop executes or runs that statement multiple times, that is greater than 1, as long as the condition is true. Or it helps us to execute some statements that may be executed or read multiple times, that is greater than 1 time. And the while loop is a pretest loop. The pretest means that it will test the condition before the statements in the loop are executed. And this is the loop format for while statement. And you can see that while the condition is true, then the statements will be evaluated, or the statements will be executed rather. This is the flow control for a while loop. So first thing what we do is we test the condition. If the condition is true, statements will be executed. As long as the condition is true, this loop will be executed one too many times. And then when this condition is false, this loop will exit. However, if this condition will become never true, this will continue forever. That means it will continue infinitely, which will consume a computer resource, a memory resource, and your computer might stop responding if it has a program that has infinite loop execution. Here is what I have said in this flow control in statement form or in verbal form. So if the condition is true, statements are executed, then the condition is evaluated again. If the condition is false, the loop is exited or it will be skipped. However, if the loop will have no false statement or will have no false condition, it will run infinitely. So for instance, take a look at this example. In this example, what you can see is that we have a counter set to 5, and then as long as counter is greater than 0 or greater than or equals to 0, then the counter will print out the value of the counter. And then the next statement actually reduces or decrements the value of the counter. So if we run this program with just a main function, what happens is that it will come first here, 5 is greater than or equals to 0, so it will print 5, and then counter will be decremented. So you know what this means, right? So counter will be now 4. So 4 is greater than or equals to 0. 4 will be printed again, again, and again. And then finally, when counter is 0, 0 is greater than or equals to 0, right? So it will print 0, and then it will decrement counter, which will make it -1. When it becomes -1, -1 is not greater than or equals to 0. So this loop will stop executing, and it will be exited. So this is the reason why we use, or this is one of the reasons why we use decrement statements, or why we have to know decrement statements, so that we can use it together with looping control. There are other things we can do with looping instead of just exiting. For instance, we can help, or we can use loops or while loop into useful cases. The first thing is when the number of iteration is unknown, or it is not predetermined. Or the second thing is when we want to validate the user input. So here, for instance, let's say we want to receive a number between 1 and 10. In this case, user might insert a number that is not correct, or that is greater than 1 or below 10. So we want to make sure that user enters a number only between 1 and 10. So we declare our variable num, and then what we do is we first we first ask user to enter number between 1 and 10, and then we receive that number and we check whether the number is between 10 and 1. So num is less than 1, while num is less than 1 or greater than 10, this is invalid number. So users will be asked to enter the number again. So we only want to receive number that is between these two. So if we receive 20 or -1, this loop will become false. Or if we receive any input other than a number, this loop will be false. This condition will be true. So we will be asked. So whenever you enter number between 1 and 10, this loop will be true, and then this loop will be false, and then the number will be exited, or the loop will be exited. So what is a counter? We've already discussed what a counter is actually. Even though we discuss it with the variable name itself as a counter, most of the time the variables that we use to control a loop are called counter. So the variable that is incremented or decremented each time a loop operates is called a counter, and it can be used to control execution. However, it must be initialized before entering a loop. As you can see here, the counter variable here is initialized here. If it was not initialized here, it will be difficult to execute this condition or to test this condition. So it has to be initialized, and it will be counted. So we had an example in our previous lectures, which is called Area 3 program. Earlier, actually, we just give a menu like this, program to calculate areas. If you want to calculate 1, if you want to calculate a square, you press 1. If you want to calculate rectangle, you press 2, and on and on. If you want to quit, you press 5. However, if user gives 6, 8, or 6, 8, or 10, we didn't have a means to execute or to check user input. So now that you understand a while loop, you can force your user, or you can force your program to input a valid menu only. So in this case, this number or this menu will be displayed, and if user inputs 6, we can tell the user choose a valid menu, and then when user puts 8, again we say choose a valid menu, and then when user inputs 2, then this means calculate the area of rectangle, or calculate the area of circle. And then if we calculate, so maybe this menu is incorrect, or this here example is correct, but if he chooses say 3, and then we ask the radius of a circle, and we display the area of a circle. So you understand, I think, the concept of what we are trying to do, if you have any experience in Java or Python. So you can be able to do this, or you should be able to do this. The one thing you should do is you can save our area 03 program as area 03 while.dart. That means our area 3 with input validation. So you can do this and update our program. So it's best if you continue to update the area program as beginning with chapter 1 or chapter 2, because we'll give more examples that is related to this function or to this program. The next thing that we'll be doing, or the next repetition that we'll see, is the do while loop. It is similar to a while loop with a little bit of variation. Unlike the while loop, the do while loop is a post test loop. That means the condition is evaluated after the statement is executed, at least once. So the statement will be executed at least once. This is the format of the do while loop. So you do one or more statements, and then you test whether the condition is true or false. So if the condition is false, at least once the condition will be checked. So in this case, this is the flow control of the do while loop. Statement will be executed, and then we check the condition. If the condition is true, then we'll check again. If the condition is false, we'll go out. So this is how it goes. And the same thing, if the condition is if this statement or if this condition never becomes false, it will be executing for infinite times. And this is specifically or specially used in the menu driven programs. Another thing about this is that some of the statements that we wrote before can be avoided. So it is a little bit more efficient. So for instance, in this case, you can take a look at this code. So int num do that you ask user like enter the number between 1 and 10. If the number is between 1 and 10, then this condition becomes false, so you will exit. However, you repeatedly do this until this condition becomes false. That means until somebody enters a number between 1 and 10. If you take a look at this code and the previous code, so for instance here you can take a look at like 1, 2 statements only, right? So if you go back to the previous statement, then in the previous statement you can see that 1, 2, 3, 4 statement. So, and also you have to write more message. So in this case you can see that This statement or the while loop takes multiple instructions. So these two lines of code or reducing these two lines of code is actually important when you think of millions of lines of codes or hundreds of thousands of lines of codes. So this is the do while loop, and you can also practice the do while loop with our area 3 program, and you can name that program area 3 do while.dart, and then you will update actually our area 3 program. And in this case actually you may see something similar to this. You'll be asked, you'll be provided a menu. If the menu you enter is invalid, you'll be provided the menu again, and then once you enter the valid menu, you'll be asked other informations to calculate the area. So the one problem with this is that the menu will be displayed one too many times. So this is one of the problems. But if you can see that, like, as the screen goes up when we are using console programming or console based programming, will be useful, especially when you are developing programs that are for system programming. So like, just practice this, but it is not really important to the thing that we will do a little bit later on, or it will be not like this when we make or when we start programming for loop. Another loop or another repetition that we can or that we will use more often than usual is the for loop. The for loop is similar to the while loop in a way that is both of them are pre-test. That means the condition is tested before the statement is executed. And in for loop, it is like a little bit advanced version of the while loop. And the difference between probably the for loop and the while loop is that in a for loop, we know how many times the loop will be executed. And this is the flow control. So first we have initial code, and then we test the condition. If the condition is true, we execute the statement. Before we test the condition again, we update the code and then test the condition. So this update allows this condition to become false, because unless the condition if the condition does not become false, it will run infinitely. We've already discussed this. This is the format of the for loop. We have initialization, and then we test, and then if this condition is true, actually we execute the statement, and then we update, then we check the test condition. So this part is done only once, and these two parts, or these three, state, test, update, and execution, are done one too many times. So let's take a look at this example which we have seen earlier. So we come here, we initialize count. For count equals to 1, count is less than or equals to 5, count plus plus. So the first step is the initialization expression. The second step is to evaluate the test expression, and if it is true, we do not come here. If it is true, we go to step 3. That means we execute the body loop. That means it will print hello, I'm here. And then, because 1 is less than or equals to 5, it will execute it, and then we update. So we perform the update of the expression and then go to step 2, not step 1, step 2. And then we check 2 is less than 5. We print, and then we update, count becomes 3, using the increment operator that you can see here. And then 3 is less than or equals to 5, and then 4 is less than or equals to 5, 5 is less than or equals to 5, and then finally when count increments, count becomes a 6, 6 is not less than or equals to 5, so we exit this loop. So I have already said that how it is going on. So the for loop has initialization, which is to declare and initialize the iterator, so which is the count, and it is done only once. The condition is tested before iteration, it's pre-test. So if the condition is true, then we'll continue to execute the statement, otherwise we'll skip or we'll exit the condition when it becomes false. The update helps us to iterate over the statement, so it will help us to control or limit the number of execution. So it is used to make the condition false, so that we can prevent infinite looping. We can take a look at this example to check our for loop. So in this case, what we did is let's go to the programming. So in this case, we try to create a program that computes the sum and the average of grades. So we declare the appropriate variables to store our values. For instance, n can be the number of courses you are taking, and the total is total grades, and average is average of the total. And we declare a list to store the grades of or the score of each course. So first, we ask the user how many courses are you taking, and then the user will insert how many courses he is taking, and then depending on that, we will loop. So for the for loop to get the grades for each courses. So how many courses? Maybe if he says 3, then we loop for 3 times and receive each input, and then we calculate the total using this statement. So we can use another for loop to calculate the total, but instead take a look at this statement. This is specific to Dart. Other programming languages use another for loop to access each value of the list and then add it onto total. But in Dart, you have, like on a list, you have a method called reduce, and this method reduce actually combines two statements, or combines two elements of a list with such operation. So for instance, what is this doing is, like, if you have 3 statements, if you have 3 elements, it will combine the last element with the second element, the third element with the second element, and then it makes the total, and then combines this result with the first element. So that is what it is doing. And then finally, to get the average is total over n, and then it will print the average here. Let me show you this with an example. So we've already discussed how JDoodle works. So if you say, like, for instance, 4 elements, you have to enter 4 elements, and then if you say 5 elements, you have to store 5 elements. So in this case, we have 3 elements, and you can see that grade of course 1, grade of course 2, grade of course 3. At this point, actually, we have to enter 22, 33, and 11, but because of the way how JDoodle works, we can't input these numbers right here. So for instance, let's say 4. In this case, we have to enter, that means 4 elements. Let's call it 55. And if we execute, we'll get another result. So the grades are 22, 33, 11, and 55. The sum of the grades is 121, and the average of the grades is 30.25. So here is what is done in this statement, in this reduce statement. This is the list, right? So what this reduce statement is doing is it will add 55 and 11. It will become 66, right? So now this 66 will be added onto 33. That means first these two will be added, and then it will be combined with 33, which will become 99. And then the sum of these 3 elements will be added with 22, which will become 121. So this is what the reduce statement works. This is how the reduce statement works. It will add the last 2 elements and then add to the next element and then continue. So add these 2, then add it to here, and then the combination of these 3, it will be added here. So that is how the reduce statement. This is specific for Dart or Dart programming language. So it will make it easier instead of having another for loop to find the total and do the calculation. So in such ways, Dart is simple. You can have for loop to have such kind of statements, and the one thing you should never forget is that in for loop it is 100% sure that the number of executions or the amount of loop we should do is predetermined. That means it is known before the execution of the for loop starts. So this is the program for the for loop. For instance, you can use this. You can apply another for loop to find the maximum and the minimum of grades. That is kind of an exercise for you to update this average.dart programming language. So by the time you submit this assignment, I want you to be able to find the maximum and the minimum grade. So to find the maximum and the minimum, you can assign, or you can assume that the first number is, or the first input is the maximum number, and then the minimum number. Then you can continue to update it. So for instance, I can say int max and min. I can say int max comma min. Then the first number I get, or the first like I can assign them like 0 0. I can say max, this is max assigns to 0, and then min assigns to 0. Then what I can do is, here when I receive the number, what I can do is I can use the if condition. If the number that I got, I can call it probably, I can check the condition here, probably, I can say another variable called num, and then probably I can receive num here, num assigns, I can print this Control X, Control V, and semicolon, and then I can add num Okay, then what I can do is I can check if num assign is greater than max. Then tab max is assigned num, and then also I can have another if statement. If num is less than mean, then tab mean assigns num. So this statement actually can easily find the maximum and the minimum. Probably there should be semicolon here. Yeah, so if I print the mean and max, I think it should be mean and then dollar max. I think this should work. Yeah, so 0, like maximum is 55, but we assign minimum to max, so maybe we should add a little bit more here. So we can't find the minimum number here. The first has to be assigned here. So anyways, you get the idea, right? So I think you can use this code in order to update your code. Let's get back to our discussion. So the for loop can have another format. Instead of using declaration of initialization, condition, and update, we can use the for each loop. And then this case, the most important part is to use the for loop with list and set. So when you have list and set collections, in Dart actually we call them collections. When you have list and set, then you can iterate over the list and the set without having to declare and update. So it will iterate over just the number of elements that list or that set contains, and then when it finishes, it will stop. So for instance, suppose you have a list of elements, you declare a new list and you add 1, 2 to the list, and then you use add all method to add 12, 2 and 1, and then if you want to print everything in the list, what you can do is the list is list that you can use the for each statement, and then for each element, that means it will store each element of the list onto this element. 1 will be stored here, 2 will be stored here, 12 will be stored here, 2 will be stored here, and then each element will be printed out. The output will look like this. And then you can convert using the method from, you can convert this list into a set. So you can see I created a set of strings, and then I use a method dot from to convert this list into a set. And we say that the set contains only what? Only unique elements. So if you actually print out each element in a set, then you can use this for each statement to print out each element, and the output of the program will be looking like this. As you can see, the two repeated statements are not displayed here, or the two repeated elements are not displayed here, because this is a set instead of a list. I hope we have a program for that. Yeah, so you can see that this is our program, and if you execute it, you will be able to see the list of elements and the set of elements. Another way of using the for loop or the for statement is to use it with nested for loop. Similar to the nested if, we can use the nested for loop to repeat or to iterate over kind of two loop statements. So the nested loop is a loop inside of another loop. So we have the inner loop as follows, and we have the outer loop as follows. For instance, we can use some fun experiments of like printing a pyramid inside by nesting a loop. So you can see that the inside loop determines how many asterisks to be printed. So 1 asterisk, 2 asterisks, 3 asterisks, and then the outside loop determines how many times. That is 1, 2, 3, 4, 5, 6. So it starts from 0. So 0, 1, 2, 3, 4, 5. So it is 6 times. So this controls the row, and this controls the column of how many loops will be printed. So there are some fun things like this, but we'll use this kind of nested for loop for other purposes. Later we'll see that. So we can use this nested for loop to solve some complex problems, and such as processing multidimensional lists. So the outer loop controls the row, and the inner loop controls the columns. We can combine like 2 or 3 loops or loop types. For instance, we can combine while loops with for loops with while loops, or do while loops, or we can combine conditions with loops. For instance, we can combine if conditions with while loops, and what you say for conditions with switch loops. So this is actually the basic building blocks of the logics of programming, combining flow controls and statements in order to guide your program. So let's discuss now some of the things we can do with loops or with nested loops. So the first thing is we can think of two-dimensional lists. So the rows are controlled by the outer loop, and the columns are controlled by the inner loop. So for instance, we can call this two-dimensional lists matrix 2, and in this case what we did is we used the multi-dimensional loop in order to be able to calculate the multiplication or the power of a number. So we have a number from 1 to 10, and when that number is raised to power 1, raised to like this, helps us find the square, and this helps us find a cube, and this helps us find x raised to 4. And you can see that we can build, or we can display such kind of multiplication table using two-dimensional lists. But the best thing about loops is when we use files and databases. So we can also create a list which contains another list. So far, if you remember, we were creating a list that contains elements, right? So each the value of each element is either a string or integer so far in our discussion. But imagine the list containing other lists. So instead of storing some kind of value here, we store other lists. So this is a list by itself, and then within that list we can store other lists such as this, and this will help us create a two-dimensional list. For instance, you can look at or you can take a look at this example, and in this case we have the number of rows and the number of columns fixed, not growable, as we have discussed earlier. So this is a fixed row and column list. So we declare how many column and how many row it is going to be here, and you can see that we create a list, and inside that list we created a list of strings. Let me go back a little and show you the difference between this one and the previous one. So in this case, for instance, we created a list of integers. That means this list will contain a collection of integers. However, in this case, this list contains another list. And then each row will have a new list. So you can see that we created a new list, and then take a look at this very interesting, a little bit confusing thing. So you can see for this list, we say create new list. So that's how we create a list. But for the list that is created inside the list, we also have a way of creating a new list. So we created a list inside a list, and then we use a nested for loop to add elements to the list of lists. So instead of the add method, however, we use just the indexes. So at each index, that means at each row and column, for instance, this is for row 1. For row 1 means this is row 1. So we add as an element, we just add those strings. So it will just have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. This is the first row. And then we increment the row. Now the row becomes the number 1 row, row 1, row 2, row 3, row 4, row 5, starting from row 0. So in this case, you can see that we can use the nested for loop to access a list of lists, or to access a multi-dimensional list. As I have said, this is more useful when you are talking about databases and files. We can create a growable list. That means the column can be growing. So here in this case, we say that a column growable multi-dimensional list. So instead of limiting the number of column, so in this case you can see that the number of column is col, and col is 6. So we can have only 6 elements, 0, 1, 2, 3, 4, 5. So there are 6 elements. But in this case, to have the column unlimited elements, we can create, as you can see, the normal one. The list will contain list of strings, but the number of columns is unknown. So we leave it empty list, and then we can add or we can use such kind of statements. So for instance, here in this case, we use actually here a combination of for loop and while loop. The reason why we use combination of for loop and while loop is because the number of row is determined. We have 2 rows, but the number of columns is not known. So the column can grow. So in this case, we say that for the first row, we say press any number to add to row 0, or press 0 to quit. And then when user presses some number, we go and type any word, and then press anything you want. We receive user input. Finally, after we receive the data from user, we can interpret the data as follows. For instance, let's take a look at this example, right? So the output of the previous example, if you just put or surround this by the main function and run it, what you will see is such kind of example. So it will say press any number to add a row 0, or to add 2 row 0, and or you can press 0 to quit. So he pressed 1, and then it says type the word, and I press 11884, and then it will ask me to press any number or 0 to quit. So I press 0. So at this point, the data that you take for 0 is over. That means row number 0 only take one information or one element. However, now press any number to add to row 1 or 0 to quit. So it can be any number, but I press 1. It says type any word. I type yellow, and then press any number to add to row 1 again. Now I want to add more thing to row 1. So I press 1. I press 1, and then it says type the word, and then I press Zalalem Jambre, and then in this case it will ask me to add to row 1 again, but I don't want to add more to the row 1, so I quit, and then I can interpret the value as follows. So I can say row number 0 is for ID, and row number 1 is for first name and last name, or last name and first name. I can assume like this, okay? I can assume, okay, every time the 0 row can be used as ID, and the first row can be used as first name and last name. And then I can print like ID is 11884, and then last name is yellow and first. But this is just to show you an example of row and column, okay? This is to show you that in one row we have just one element, and in another row we have 2 elements. So the row can grow and expand. So this is kind of a limited number of row and dynamic number of column. This is just to show you an example. But when you receive user input, actually you should give some descriptive way of explaining the input and the output. The next one is to have a dynamic column. However, to make a dynamic column, you have to have the column, to have a dynamic row or row growable multidimensional list. You have to receive the number of rows from the user or from some kind of method. So it's not like as in growable column, okay? So in this case, you can see that the user can determine the number of rows. So you can see that please enter the number of rows, and then the user will enter the number of rows, and we can use this row number to make our row growable, or we can have some kind of method that will return the row, and then we'll use this row to make our row global. And then the number of column can be limited. However, if you want dynamic row and column, and then in this case, instead of using just a fixed number, you can just put it as an empty list. But however, the number of rows still should be determined from user input or from the method. So this is the use of multi-dimensional lists. And as I have said earlier, you can use, for instance, in this example, nested for loop to interact with multi-dimensional list, or you can use nested for loop together with another while loop. So this is just to show you how you can be able to use your knowledge of row and column to get or to store the information that you are dealing with. So one of the examples that we can think of using multi-dimensional list is matrix addition. You may think why this matrix addition is important, right? But when you think of like if you want to become a data scientist, or if you want to work within machine learning and artificial intelligence, you actually have to deal with matrix and matrix manipulation. So you'll have to have matrix multiplication. So you have to run a program that multiplies matrix, that adds matrix, because information is stored in artificial intelligence in such a way or in such a format. So you can use, for instance, a nested for loop to be able to run or to add your matrix. And if you take a look at this example, we have two lists or two matrices or two-dimensional matrices, A and B, and we use nested for loop to add them. And if you execute it, you can see that it becomes 8, 8, 8, 8, 8, 8, 8, 8, 8. So it adds this matrix. I formatted this matrix such that the output looks like this, so that it is a little bit understandable for you easily. But if you change this number maybe to 9, you'll see a different number around here. So you can see the last number becomes, or the last matrix addition becomes 17. So you can use a nested loop to deal with matrices as well. Let's go a little bit darker and a little bit darker. So if you talk about complex structures, or you can think of collections, or you can use collections in order to make a complex structure. So instead of using list of lists, you can use actually map of lists and map of sets in order to create such kind of complex structure. For instance, think of this element or this map. We've already discussed map in our chapter 2, I think, if you remember. So you can create a map of, usually we created like a phone number. You can if you remember, we created like a map of strings and strings to store phone number of other people. But if you take a look at this, we can create a map of string and list. So the key is string and the value is a list, and we can use this map to be able to store the count of medal during the Olympic Games. For instance, in this case, you can see that Republic of Korea has 2 golds, USA has 1 gold, Italy has 1 gold. They don't have, like, probably USA have 1 silver, and ROK or Republic of Korea has 1 bronze, whereas USA has 1 bronze and Italy also has 1 bronze. So you can see that we can use the combination of map and list to be able to have a complex structure of storing file. And we can also have map of sets. And the map of sets can be, the key can be string, and then the value of that key can be set. And if you remember when we work with sets and the color of flags, so you can see the number of, the countries and the color of their flags. For instance, the ROK and USA have the same, like blue, red, white, blue, red, white. Italy has green, red, white, so it has to be green here. So you can see the combination of collections. So the map itself is a collection, and then the list itself is a collection, or the set itself is a collection. We combine these collections in order to be able to create this kind of what you say complex structure. So when you work with files and databases, you'll have this kind of complex structure, and when you want to receive that complex structure, or when you want to read that complex structure from files and databases, you can create such kind of complex structure. Another thing that is darker and darker is to use sentinel values. What are sentinel values? We've already actually used sentinel values in our previous programs. So the sentinel values allows us to find or to indicate the end of data. If you remember, when we talk about while loop, we say that we use a while loop for statements or for repetitions that is not known, or the number of when the number of repetitions is unknown, we use while loop. And in that case, we can use the sentinel values to make the condition false. So for instance, in this case, we can have such program, and we can use -1 as a sentinel value, or as a terminating input. So we can ask user to enter points earned, like when you purchase from eMart, or when you purchase from any other shop, for instance, you may be able to find, or you may be able to see that you receive some points, right? Now the question is, will you ever receive a negative point? No, you will never receive a negative point. If you didn't receive any point, your point will always be 0. So that means whenever you enter a negative point, that means you want to quit this program. So in this case, for instance, the current total point is 0, and the pointers you have is unknown. So you'll be asked to enter your pointers, or -1 to quit. So if you enter a number that is not -1, then you'll receive, it will be added to the total. So if it is not -1, because pointers should be greater than 0 or greater than -1, so you receive the pointers and you update the total, and then you'll be told enter points earned, and then you put that number, and this will continue forever until you input -1. When you input -1, this program will quit. Sometimes you can use numbers such as -999, or you can use numbers, letters such as Q or other things. So it will help us terminate the while loop, and that is a sentinel loop. We can see an example for this. For instance, we can call it what you call guessing game. Let's go to our program and explain. So for your guessing game, what we do is you enter, like the program creates a random number, and then that random number will actually be matched with your input, and if the program guessed the number you input, then he will win. Or if the program does not guess your number, then you will win. This is kind of a game. So one thing before we go ahead and discuss this program is to create a random number. You have to import the math library, and this random object, which we'll see what object is. So this random object is found in this library, and it will help us create a random number. So we have int rand, and then in this case, if you want to quit, you can actually press Q, smaller or capital Q. In this case, you can see that you'll be prompted to enter a number between 1 and 10. This is the number you enter, and this is random number will be generated that is between 1 and 10. And then if the number that is generated and the random number, the number that you entered and the number that is generated is equal, that means the computer decides your output or decided guessed your number, so he will win. But if he cannot, or if the number is how to say, not the same, then you will win, and your number will be given, and other things will be displayed. And if the number is probably between, if the number is not between 1 and 10, then you'll be asked to enter another number. So to play this game, you can see that this game actually uses the while loop and the do while loop. So you can see that it is the while loop and the do while loop. So the while loop allows you to play the game more than once, and the do while loop gives you to test at least, or to check at least once. And since we cannot do this with programming language, I mean with IntelliJ IDEA, so if you want to play multiple times, this is what you have to do. So here is an example. So you can see that I press 2 and then play again, 3 and play again, 8 and quit. So if I run this game, for instance, the first time the computer wins, like I win, the second time you win, and the third time you also win, because your number is 2 and the computer name is, the number was 2, and in this case your number was 3 but the computer number is 10, and in the third case the number is your number is 8, the computer number is 3. But if I run this program again, it might have different result, because the number the computer generates is random. So in the second round, probably you can see that you win all rounds. So you win, you win, you win. So that means you can use multiple nested loops and multiple numbers as follows here in JDoodle in order to play this game. So this is the way you can use sentinels. You can, how to say, improve this game for fun. This is not an assignment. You can improve this game in order to play rock, paper, scissors. For instance, you can display menu like 1 for rock, 2 for paper, and 3 for scissors. and you can allow user to select. When user select between from 1 to 3, and computer can select between 1 and 3, and then it will play with you like rock paper scissors. So you can practice with this at your home. This is not kind of an assignment like the others that I give. This is just for fun. And you can use random numbers to do more than having fun, though. You can use random numbers to play games and to create some kind of simulations. And I've already said that to play with random numbers, you have to have or you have to import the Dart math library. And when you create games such as rolling dice, spinning the wheel, or pick a card, you can use random numbers, or you can use random numbers to do some kind of simulations. For instance, let's take a look at this Monte Carlo method of simulation. In this case, our goal in Monte Carlo method or simulation, our goal is to approximate pi. What is pi? First, let me just briefly describe what pi is. Pi is actually when the circumference or this round of the circle or is divided by the diameter of this circle. It will always give you this kind of number. You can actually simulate this in your example. So, for instance, you can create a dart that is with a radius of 1 unit, and then if you throw some kind of dart in this circle, like for instance, some of the darts you missed the dart, that means the dart you throw can be outside of the circle, and some of the dart you throw will be inside this circle. So if you throw a dart, like if it enters here, it's a hit. So a hit are inside the circle, and a miss is outside the circle. So if you do this like thousands of times, and then if you count the number of tries, like how many times you try, and the number of hits, and then if you divide this ratio and multiply by 4, you can have some number that is similar to this. So you can have a program to simulate this. So that is called the Monte Carlo simulation. So you can see that the number of tries is 20,000 times, and to simulate random number, or to simulate secure random number, you can use a random number. So for the number of tries, actually you create a random number r. If you multiply this random number by 2 and then subtract -1, you'll get the x coordinate. If you do the same thing and -1, you'll get the y coordinate. And then you do this composition or this calculation. So if x squared plus y squared is less than or equals to 1, then it is a hit. So we increment the value of the hit. But if it is greater than 1, it is outside of the circle, then it will be just a try. And then you can print the estimate of the pi by using this calculation. So to see this in our example, you can go to our JDoodle and simulate this. So at this point, we have 20,000 tries. Because we have 20,000 tries, you can see the number of, for instance, for a number of tries, you calculate the x and y coordinates, and you check whether it is inside the circle or outside the circle based on this kind of calculation. X squared plus y squared is less than or equals to 1 if it is inside the circle. And if you run this program, you can see that this gives you like 1.12, but pi is actually 3.14. If I increase the number, for instance, the number of tries to 50,000 won, 50,000 times, then it will become more and more accurate. So you can see that now it becomes 3.14, which is close to pi. If you run this program again and again, you might get a slightly different result, but when you increase the number of tries, then this program becomes more accurate and accurate. So you can use loops in order to be able to simulate such kind of real life experiments. That is the point of this discussion. So this will end our loop discussion or repetition discussion. This is a bit longer lecture, but I hope you have some idea on how to control your flow using if loops and if conditions and while, for, and do while loops and switch cases. So this is how you control your program, and I will see you or I will talk to you in the next program. This will conclude our discussion. I hope you had some idea of the concept of flow control, such as using if conditions, switch cases, while loops, if else conditions, and do while loops, and for loops, for each loops. So you can use these mechanisms in order to be able to control your program, and I'll see you in the next lecture.